All right, greetings. This project, this least squares regression activity, is designed to make an equation to predict the number of bacteria that will be on your hand after you use something like Purell or a hand sanitizer, how many bacteria colony counts there are. So the first step you need to do is put these data lists into our graphing calculator. Double check and make sure you have the correct points in your calculator, the correct before colonies and after colonies. So after you have the data lists in your calculator, the next step will be to make a scatter plot of this situation. So using my calculator, I'm going to do second y equals, turn on the plot 1, make it a scatter plot, put in my before list, and put in my y values as my after I have used the gel. I'm also at this point going to hit my y equals and clear out my equations, hit zoom 9 and I get my scatter plot. Transfer that onto my worksheet and also include the axis title and scale. So this is, I'm going to call it hand sanitizer. And this is the bacteria before I use the sanitizer, and this would be the bacteria after. The other thing we need to do for this plot is to get our window descriptions so we can give some meaning to our axis labels. And so I am going from basically 1 on the x-axis to approximately 21, and on the y-axis it looks like I'm about at -2 to 15. Okay, taking a look at this plot then with my eyes, I see generally that they're headed uphill, and we have a suspicious character kind of up on this part of the graph, but other than him, I'm going to say this scatter plot displays I'm going to call it moderately strong, positive, linear association between before bacteria colony counts and after the hand sanitizer bacteria colony counts. Okay, that's the first step, is to take a look and make sure I don't see any curves, which I don't, and I'm thinking it's moderately strong. Now I'm going to use my calculator to verify what my eyeballs are telling me. To do this, I choose Stat, Calculate 8 for linear regression, and I will bring up my lists before, the bacteria counts before, and the bacteria counts after. I'm going to use my secretary, which we have named Beth, to stick the equation line in my y equals editor for me, so it will appear on the screen. Press enter, and if my r and r squared are showing, then my catalog diagnostic tools are on. So this r is 0.76. And according to the scale we've been using, that's pretty good. So I get an R of 0.76 if I round properly, 0.764. And this correlation coefficient verifies the moderately strong positive linear association So basically that's the same sentence I used to verify the scatter plot. And now I'm using it to explain what the R of 0.76 tells me. All right, the next step is to take this information that we have gained from our calculator and to get the regression line. All right, remembering to put our hat on, I have y hat equals negative 1.63 plus 0.75x. And I'm going to make myself a little note that x is the before count and y is the after count. So I need to put this line now back on my scatter plot. And to do that, I'm going to just hit graph on my calculator. And that shows me where the line is hitting a couple different points here. And I'm going to use that information to place the line through my points and try to get it as accurate as possible. Let's see how that looks compared to what I saw in the calculator. That's pretty good. Get this down a little lower maybe. Okay. All right. So now I'm going to interpret the intercept. What does negative 1.63 mean? When the bacteria colony count before disinfectant is applied equals 0, then the after bacteria count is predicted to be negative 1.63 colonies, which doesn't really make any sense, but that is the interpretation. So what is the slope interpretation? When bacteria counts before disinfectant is applied, increases by 1 colony, then the bacteria count after we apply the disinfectant is predicted to be, or to predicted to increase by 0.75 colonies. All right, finally we're going to make a prediction. If I look back at my original data, the smallest before count is 3 and the largest before count is 19. I'm just going to take 25, which is outside my range, so I'm doing extrapolation, which sometimes can cause us problems. So I'm picking the before bacteria count to equal 25 colonies. And if I use my equation, y hat equals negative 1.63 plus 0.75 times 25. And I need to use a calculator to do that, so I will quit out of here. Negative 1.63 plus 0.75, I believe it is, times 25 gives me the answer of 17.12. So the after would be 17.12 colonies. Is this feasible? I guess so. I would hope that maybe I'd get rid of a few more if I washed my hands with Purell a second time, because that's still a lot of bacteria colonies. But that is the problem with extrapolation. Okay, that's the first part of the video. In the second part of the video, I will continue with the rest of this.